Hi. In this lesson we're going to take a look at Newton's second law. So a couple things to keep in mind about Newton's second law, and a few things that I'm going to circle in our equation here. So for Newton's second law, we oftentimes are told F equals ma, force equals mass times acceleration. But there are a few subtleties that we want to make sure that we understand well so that we can apply this to physics questions. The first thing to point out is this, that when talking about force, it's talking about a net force. So that means that here your net force is going to equal the mass of the object times the acceleration of that object. And the reason that's important is because forces can oftentimes oppose each other. So for example, in regards to Newton's first law, we talked about how an object at rest will remain at rest unless acted upon by an external force. And I gave the example of someone pushing me and me being moved to the side as a response. For net force, we have to keep in mind that an object at rest is only going to be moved if a net force is applied. And that means that if someone were to push me from my left side with a force of 10 newtons, and someone were to push me from my right side with a force of 10 newtons, those forces would cancel each other out and I would still be stuck in place, being pushed with 10 Newton force from two opposing sides. But if I had only one of those forces applied, if someone pushed me, let's say, just from my left side with a force of 10 newtons, then I would accelerate as a result, because I would have a positive value for my net force, and therefore I would have a positive acceleration. The other important thing to note about Newton's second law is these little arrows over force and over acceleration. So what do those arrows mean? If you said that those arrows represent vectors, you're correct. And what vectors mean is that direction matters. So whatever direction our net force is applied is also going to be the direction that our object accelerates. So for a simple example, if we had, let's say, an object with a mass of 10 kilograms, and we wanted to accelerate that object at 5 meters per second squared, then what net force would we have to apply to that object in order to make a 10 kilogram object accelerate at 5 meters per second squared? So to do this calculation, we simply plug into our formula. F net is equal to mass times acceleration. And here we have a 10 kilogram mass and a 5 meter per second squared acceleration. So we have 10 times 5, which would give us 50 as our net force. And what are the units for force? If you said newtons, you are correct. Newton's laws. Newton came up with the laws, so Newton gets to put his name on the units for force as well. So the net force required to accelerate a 10 kilogram object at 5 meters per second squared would be a 50 Newton net force. For further questions, please see our other videos on Newton's laws or visit our website at www.sandersontestprep.com. The link is in the description below. Thanks for watching.